Okay, I want to welcome everybody to Lime Time in Texas, which is our podcast series. My name is Dale Rand with the Lime Association of Texas, and today I'm going to cover a topic talking about soil stabilization and really understanding how soil grain size comes into effect when you're considering stabilizing the soil. So I'll jump right into the presentation here. So I'm going to start with talking about the definitions of what a coarse grain soil and a fine grain soil is so that we kind of understand what we're talking about here. So a coarse grain soil is going to be something that's relatively large grain size. It's something that you can see with the naked eye. You can, for example, here sand or gravel, usually you can pick up a single grain of sand or a single particle of gravel. So it's relatively large compared to the fine grain soils. So they have relatively small surface area. So typically a coarse grain soil is not going to be very cohesive. It's not going to, by cohesive means it's not going to really stick together. It's going to have typically a low plasticity index. It's just not going to be very expansive. So the good thing about coarse grain soils is they have very good drainage characteristics. So if you have, for example, a dry sand and you wet the dry sand, the water will typically run right through it and it'll dry right back out. And gravel is kind of the same thing. So they don't really maintain water or retain water. So if they don't do that, they're not going to be expansive either. So they have good strength characteristics, support characteristics of just being able, so you can, if you're building a pavement, you would much prefer to have sand and gravel to build on top of rather than fine grain soils, which when I get into the definition of that in a minute is more in the talking about silts and clays. So that's pretty much the definition of a coarse grain soil. Again, if you can see it with your naked eye, it's probably without magnifying it, it's probably a coarse grain soil. And coarse grain soils can go up, and I'll give an example in a minute, up to very, very large particle sizes. The next one is the fine grain soils, and so the other category here, it's in the definition of that, or the characteristics of they're very small to very, very, very tiny size particle sizes. So our examples here are silt and clay. Silt's a little bit coarser than clay. Clay is the finest of all of these, and that's one of the reasons it has some very unique characteristics. But these, you typically cannot, these are finer, like a silt, for example, is going to be finer than flour that you would use to cook with at home, typically in that range. You really can't get down and look at an individual particle very well, but you don't necessarily need magnification. For a clay particle, you're going to need some type of magnification to be able to see that because it's not visible. An individual clay particle is not visible with the human eye. So the other characteristics of a fine grain soil is they have a high surface area, so they attract water. Clay in particular will attract a lot of water because it has a lot of surface area and it has a negative particle charge, so it will draw water into it. Silt's a little bit different. Silt is, and I'll talk about silt in a little bit more detail in just a minute, but fine grain soils are what we describe as being poorly drained. In other words, if you have a clay soil and water gets into it, it doesn't come back out of it very easily. And what happens with that, it makes it highly expansive. So if that water coming in, the water going out, makes it want to expand and shrink back. So particularly talking about focusing on clay soils here. Now, I'll talk a little bit about silt, but I don't want to focus on that much because silt is not as common. We don't see it that much in Texas. There are silty soils in Texas, but not nearly as common as the clay or the sandy soils. But silt is unique. It's a dispersive material. So unlike clay wants to all stick together and form great big clods. Silt wants to disperse and fly away. It's a very light and doesn't stick together. So fine grain soils typically have poor strength or characteristics, support characteristics for a pavement. So most of the time when we're talking about soil stabilization with either lime or more typically lime when you're talking about fine grain soils, you almost always have to stabilize these materials, or you're going to have to come in there and use a select field and replace these bad materials because they're not good to build on top of. So the other thing that's characteristic about, one characteristic, and I'll say about clay in particular, it has a lot of what we call amorphous silica. So it's made of silica and alumina, and those are those very, very fine molecules of silica and alumina are, when we say amorphous, that means they're capable of changing. So unlike a big sand crystal, a particle of sand, it's pretty stable. It's hard to break that down. It's hard to change it into anything else. But under the right conditions with a fine-grained soil like clay, you can add, for example, when we use lime, we add calcium to it, and we're able to change the characteristics of that soil. So I'm going to just show a picture that I stole off the internet that somebody in Europe took this picture. And so this is every type of, what you may not realize is almost all soils, or really all soils, are categorized by their soil size, not by the characteristics of, so a definition of clay, for example, there's a very specific particle size. And so I'll go through all of these. Starting at the bottom there, you're looking at a strata of just boulders, and then when you get in there into the middle, you're looking at a strata of what we call cobble. You go from cobble up into, as you go up that stack there, you get into the gravel size, and then once you get into the finer than gravel, it goes into the sand. Once you get at the very top of that layer up there, you're getting into the silts, and then finally on the very top, the very finest is going to be the clays. So all of these are deposited naturally. Now, they're not deposited in nice uniform layers like this. So out in nature, you usually find a mix of all of these things together. But somebody went to the effort, so I'm going to steal the picture and use it here, of stacking these up and showing you. So it's a very good graphic of showing what all those look like. Now, I'm going to show that picture a little bit smaller here and talk about the sizes. So pretty much all the soils in the world, and I don't normally think of cobble and boulders as being a soil, but technically they are considered soils. But we normally think of just the upper part of it, the clay, the silts, the sands, and then into some of the gravel sizes. But all of these are deposited naturally. The way that I know by looking at the picture that these are naturally deposits, if you look at how rounded the boulders are and the cobbles are, that means they've rolled down a river for miles and miles and miles and rounded off all the corners of that over time. So they've traveled a long way to get deposited like they are. The only other type of soil that you'll typically see is what we just call crushed stone. So I live for example, in the Austin area, where we have deposits of limestone that are, sometimes over 100 feet deep, and we go in and blast a whole wall of that out and run it through a crusher. We make all of these you can make all of these same sizes, with the exception of probably clay and silt, out of just crushed limestone, for example. They're a lot more angular looking, and so, but that's the other material that we use when we're building particularly roadway bases and things like that, or any kind of foundation. But again, if you look at the very top, and the reason I know that this picture came from Europe is because for some reason the Europeans use a comma instead of a decimal point. So when I show that the clay is comma 0.002, think of that as 0.002 or 2 microns. So that's 2/1000ths of a millimeter. Now silt starts at 2/1000ths of a millimeter, goes up to 63/1000ths of a millimeter in size. Then sand, so to give you an idea of a 63, so if you think of flour at home, you're kind of in that range of maybe 63 millimeter. If you start with sand, this goes from 63 millimeters up to 2 millimeter, 63 thousandths up to 2 millimeters there for sand. Now that's going to be 2 millimeters is about 2 sewing needles wide, is how wide that is. So that's not very big still when we call it sand. So sand can be fairly small, but it gets up to, at least it's visible and you can pick up a single grain of sand. Gravel will go from about 2 millimeters up to 64 millimeters, which is about 2.5 inches. Above that, we call it cobble, from about that 2.5 inch range up to about 10 inches. And then above 10 inches, we call it boulder. So that's pretty much all the soil types in the world that you really need to know about. If you look at just those top 3, and I'm talking about the clay, the sand, and the silt, they have some very unique characteristics, and this little soil triangle will show a lot of that. But this is when we're dealing with soil stabilization. The first thing that you need to know is, hey, what type of soil do I have that I'm trying to stabilize? So if it's coarser than sand, it's going to be gravel, okay, in this example, because gravel will go up to about 2.5 inches. But in soil stabilization, this is typically what we're looking at, is either a sand, a clay, or a silt. Now again, these normally don't come nice and neat to where you just see just a pure clay. So if you went to the very top of this pyramid, that's pure clay that you can make pottery out of, okay? Has nothing else in it. It's just pure clay. If you go to the bottom left-hand corner, that's just pure sand that has nothing in it, nothing else in it. And then the bottom right-hand corner is silt, okay? And silt, I kind of mentioned before, is not as, you don't see it as frequently throughout the state of Texas, but it is, you do need to know about it because it has some unique characteristics that are not necessarily good in the construction industry. So typically, more commonly, we're dealing with clay and sand, but most often you're dealing with a combination of clay and sand. And this is one thing, I guess, a lesson learned for me. I never really quite knew what loam was, but the simple definition of loam, if you look at this, is anything that is a combination of silt, sand, and clay. And any kind of combination we call loam. So I used to go buy topsoil for my yard, and the people selling it says, oh, this is a sandy loam or this is a clay loam. So, okay, so I'm going to go through and just talk about some of the characteristics of each one of these. And let me start with clay. So if you look on this left-hand side there, and you go up the little pyramid, as you increase in the amount of clay from 0 up to 100%, I'm going to talk about these characteristics on the left. So typically the strength will go down the more clay that you have in that soil. The cohesion will go up, so it's going to stick together a lot more. The plasticity index is going to go up, so it's going to have more propensity to expand and to shrink and swell. The particle size goes from something you can see to something that you're going to need to magnify, sometimes several thousand times to just be able to see the particle size. That clay is that tiny. And clay has very poor drainage characteristics. It grabs hold of water and it doesn't want to let it go. So now the additive that we typically use for clay is obviously, and I will say obvious to me because I work for the Lime Association, that's right in our wheelhouse, and that's the reason we do lime stabilization, because lime uniquely stabilizes clay like nothing else. Now, when you move into some of the other ones, let's just get silt out of the way. So I'm going to come down the right-hand side of this pyramid. As you go from 0 to 100% silt, first of all, let me tell you, the closer you get to 100%, the more in trouble you are. So you go from clay, which kind of described the strength properties there, but as you go down there, so typically silt has very poor strength properties. It is not cohesive. It doesn't really stick together. The PI of silt, particularly as you approach 100% silt down there, is very, very low. So sometimes you may test a soil and think, oh, I've got a good soil. It's a low PI, just like a sand would be. But it's not. If it's got a lot of silt in it, it can fool you into thinking you've got a good soil there that's not going to be expansive. But silt is really probably the worst of all three of these to try to build anything on. So the size is, again, silt is very, very small, but it's still quite a bit larger than clay. Drainage characteristics, you normally don't think of drainage characteristics with silt, because typically if you have silt, you need to get rid of it and bring in select fill and not build, particularly if you're closer to 100%. And I'll give you one quick example where we saw a project recently up in the DFW area, had a very expensive failure, big change order, and what they found out that was a silt that had some clay in it, but it had enough silt in it that it was a very low PI material, and so the contractor brought it in as a select fill, tried to use that, and didn't have any kind of strength characteristics, and they had big problems and had to tear out a bunch of pavement and rebuild that and go back in and actually lime stabilize that. So the additive you would use for, there's no additive that you need to use for silt. You mainly just need to get rid of it. Now, as you have sand, we'll go from left to right over here. As the sand increases, I'm going from right to left on your screen. As you approach 100% sand, so now the good thing about sand is it has very good strength characteristics relative to everything else here. It does not have good cohesive properties, so it's not going to really stick together all that well. But most of the time when you find sand, it has at least a little bit of a clay or a little bit of a PI into it to kind of stick it together. But it's, generally speaking, if you have, the cleaner the sand is, the lower the PI, the lower the cohesion. The advantage of that, though, is also it has higher drainage, so water's not going to sit in there and expand and shrink and swell. You can kind of deal with that. The additive that you're typically going to use with sand is Portland cement concrete. Is the most common one that we see used. If it's when you get a little bit coarser than sand, I mentioned a little bit earlier, you get into the gravel size. So gravel gets into, you can use asphalt, for example, to stabilize gravel. You can use some combinations of fly ash and lime on some of those that are in that range that are not extremely sandy, but generally speaking, you're going to use an additive such as Portland cement on those type of materials. So I'm going to stop right here at this point, and I'm going to leave it right here on the soil pyramid and just explain that you need a basic understanding of what kind of soil that you have out there, and that will tell you and kind of direct you into what type of soil stabilization that you're going to need for the project. And again, at the top of that pyramid, you're typically going to use lime. On the bottom left, you're typically going to lean more to using Portland cement. The bottom right, you're going to definitely want to use select fill. Hopefully you learned something a little bit new about soil types and grain size, but basically grain size is everything when it comes to classifying what soils are, and having a good understanding of that will kind of direct you into how you need to stabilize that soil. Thank you. Thank you for watching this episode of our podcast. If you want to learn more about the use of lime, reach out to us on our website at limetexas.org. You can also email me at dalerand@limetexas.org. And please follow us on LinkedIn and subscribe to our YouTube channel. Thank you for watching.